So the important thing about these formulas is not sort of remembering them in detail or using them to calculate, but to get an idea of how these factors interact. So if one gets bigger, what happens? So for instance, if the focal length goes up, the F number tends to go up, assuming the objective diameter stays the same or about the same. Okay, the other thing that's worth paying attention to is the true field of view, which is how much of the sky you actually see. And you might think, we normally out of our eyes are assumed to see 180 degrees from here, which I can barely detect with my hands moving, to here. But you start looking through a telescope and it gets smaller quickly. And that has a very pronounced effect on how you know what you're looking at in the sky. Because if you start looking through something quite small, you don't see very much of the sky, so you can't orient yourself with respect to other stars. Okay, and this gives you this table that I put in, gives you a sense of what the numbers come out to. It's a little rough, but it's still indicative. For instance, eyepieces tend to come in two diameters, 1.25 inches and 2 inches. There are others, as you'll see tonight. And it's not required, but if the people who make eyepieces like to know how big the hole is that they have to go into, because it has an effect on the market, of course. So things have sort of stabilized on these two values. Okay, so if you think of the eyepiece diameter as 1.25 inches and 2 inches, which is actually bigger than an eyepiece allows in. And two focal lengths, you can see how much of the sky you can see. Basically, almost none. So that's extremely important, because if you start dealing with a 2,000 millimeter focal length, as people who want to see into deep sky do, because it helps get the magnification up, they have to know what they're looking at and how to find it, because what they get to look through is very, very narrow. I mean, I think 30 degrees is on a clock between 12 and 1. That's 30. And if you have a 2,000 millimeter focal length with a 2-inch eyepiece, which is rather big, you only get to see 1.3 degrees. So I think this is an extremely important observation for beginners, because there's a great temptation to want high magnification and high focal lengths. And a consequence of that is you don't know where you are. Take it from experience.
Michael, speak up.
Okay. Next. Oh, come on.
There it is.
Oh, it's so good. Good. Okay. So here's the first kind of telescope. This is the classic one. It uses lenses. The light comes in from the right. In this case, it has two lenses, and I'll explain why in a moment. And the eyepiece goes at the end. And two important things are missing in this diagram. It's a bit elemental, but still gives you the right idea. One is there's no focuser. So if you want to know how to focus, it's a little obscure. The focuser is the thing that goes in here and basically allows you to move the eyepiece backwards and forwards. Okay, so it's actually changing the focal length by a little. And the other thing that's missing is if you look around at all these telescopes, you see there are right angle pieces. So the eyepiece doesn't actually stick out the back so much as go up. And that unit is called a diagonal. It's just a mirror. And the point of it is to allow you to look comfortably into the telescope when it's turned up at the sky. You know, so then the eyepiece is like out here. Okay, next. So one of the difficulties with refractors, which is what we just looked at, is they're limited. It's expensive to grind glass. And they also are subject to chromatic aberration, which results from the fact that different wavelengths of light are bent differently by lenses. So if white light is coming into the telescope, it's hard to get all the colors to meet and focus in the same place. And in order to obviate this, what's done is more lenses are put in, which have the effect with different, usually different composition, different glass, which has the effect of bending the different wavelengths differently and bringing them to a focus point. And you can see in this case that red and blue have been brought together, but green hasn't. Green is over here. And so you can get refractors with 2 lenses like this, or you can get them with 3, or you can get them with 4. Mine over there in the corner, the white one, actually has 2 of these things, one at the front and one at the back, both facing each other. And the effect is to get rid of aberration. Okay, next. So here is a fellow who was looking for high magnification and built himself a telescope. Here's a guy after my own heart, although it looks like it would be basically impossible to look through this telescope. You can see what contortions poor guy has got to be in to look. The thing must be 15 or 20 feet. I don't know how big this is because the picture didn't come with any diagram. But you'll see he had to build his own sort of flagpole to hold it up. And so he raises and lowers it on like a clothesline with a cleat and a pulley. You can barely see it. And then the other thing that's a little hard to see, collapses into units of maybe 4 feet. See that this is thicker than that. It's sort of hard to see up there. And it must fit into this bag when he's done to carry it away. But you have to think of those formulas that we were discussing before and what effect this has on this guy's experience. He's got a huge focal length. So the amount of sky he can see is very, very small. Plus the fact that if the wind blows, I don't know what he's going to do. Because as far as I can determine, the telescope is only hanging from the pole. It's not actually fastened down, but it's hard to be sure. Anyway, so much for him. On to the next, please. Okay, so with the use of mirrors, we come to a Newtonian reflector. And in this case, the light comes in from here again. It goes to the mirror and it gets reflected back and then reflected into, this is like a focuser, you see? And then here is the end of the focal length. And so the eyepiece is in the front of the telescope instead of the back. This kind of telescope, of course, is also subject to various problems. But one of its great virtues is it's much less expensive to make bigger ones. So that if you want a big telescope because you want a big focal length or a big aperture, which allows in more light, this is usually the way people go. Next. And here is an example. This is a particular kind of Newtonian. It's called the Dobsonian. And you'll see one, and there's one in the corner. It's a lady's. The base rotates at the bottom, and the telescope changes altitude up and down. with this thing. And it's all just done by hand. The eyepiece is over here with the focuser. There are the focuser knobs at the top. Sometimes when you have a large focal length, you want a smaller telescope to go with your big telescope because it'll give you a bigger field of view. And so you can see that on the back. I think he's got a telescope on the back, a finder scope. What are the disadvantages? This is a kind of telescope that you can make for yourself. You have to grind the mirror if you're going to make it yourself, the way Mario is. And so you can look at that later. But if you're interested in the details, if you look on YouTube, you can see a YouTube by John Dobson, who invented this particular kind of telescope. It shows you how to make it. He's actually making a big one. I think it's about 14 feet long or something. Anyway, the problems with this kind of telescope, when you start going big, are evident in this picture. One, you can see that the eyepiece is above the guy's eyes. So that means he has to stand on a ladder. Okay, that's step one. The other thing is, you notice the vehicle in back of him. That's an important consideration too, because if you're going to move this thing around, you need some kind of truck.
That's a nice vehicle back there.
I'm not casting aspersions. I'm just saying, you know, you buy into something like this, it doesn't end with buying the telescope. Okay, next, please. Now we come to a catadioptric, which is a compound telescope, a mixture of a lens and a mirror. Why does it matter?
So you'd be on the camera?
Oh, people have to see me too?
Yes.
Okay, so light comes in, it goes through a lens first. So you can see the light is being refracted here, see how it's bent? And then it goes back to the mirror. And then it gets sent back. It's a little hard to see in this diagram. The mirror reflects it back, but there's another mirror on the face of this lens here. And so the light reflects back through the back. This is where your focuser would be, and there's your eyepiece. Okay, and an example of that is right here. That's a modern one. And the virtue of this is you get a small unit. Tends not to be that heavy unless you have a lot of glass, or unless you get a big aperture. They start getting bigger, the pounds go up. I noticed that the telescope that which was of this kind that Mario was trying to sell this morning.
Salt.
Yeah, congratulations. Wow. It was 14-inch aperture, but 70 pounds and 2,500 millimeter focal length. So that means very small field here. Okay. So next, please. So here's one of my astronomy heroes. His name is Ed Ting. I didn't catch him at an optimal moment. He looks a little confused, but he isn't. You can find him on YouTube. He has a whole bunch of lectures on different kinds of telescopes, how they work, what you should buy, what you shouldn't buy, his experience with big ones, small ones, everything. He's really a sharp guy. Anyway, what he's exhibiting on his table is 3 of the kinds of telescopes I've been talking about. You have the refractor on the left, the Newtonian in the middle, and the catadioptric on the right. And all of them have the same aperture. So that gives you an idea of how big a unit this is only 6-inch aperture. So it gives you an idea of how big things can get. Okay, I'm done.
Thank you.
Thank you.
been acting up, it doesn't work, just say next one. Raise your forward back.
Hi, this is my intro to observing, basically very basic. So let's see this over. Okay, so this is all you really need to go observing. You need the sky. And now it's not working.
That's what I was worried about. Hang on, we can solve that.
You need your eyes next. And nothing else. Although, and then there's one more. But you do need something to look at. So this being New England, for where most of us are, we have lots of clouds to look at. So lots of times, this is all you can see. But it's kind of interesting to know that there are different kinds of clouds. You get your cirrus, you get your cumulonimbus, and all the other kinds. So basically having a low, middle, and high heights. You can look at sunsets. Also, the clouds make interesting sunsets. There's cloudless, they're not so interesting. You can look at the moon. Just say there are different phases of the moon, so you see different things, and it's always interesting if you have something you can look at the terminus of the moon. You see crags and valleys, but it's easier to do that with a telescope. You can see a lunar eclipse, and see the next total lunar eclipse will be in March 14th, 2025. So we got a bit of a wait. Okay, you can also see constellations once it's dark, obviously. And so some of these down at the bottom are stuff you can only see when you're further south, but we can see most of the northern constellations, most everything above the blue line there. And you can see meteors. Oops, sorry. And some of these have gone by already, but the next one is the Delta Aquariid in July 29th and 30th, but there are a few more well-known ones that can be seen in the late evening, like the Draconids in October, and Northern Taurids in November, and Andromidids later in November. It's just kind of fun to see what that's associated comet that creates the dust that causes the meteor shower. It's kind of interesting. And we can see planets, not all of them at night or right now, but if you right now you can see Mercury in the west. It sets around 8 p.m. so it's already gone. Venus in the west, it sets around 9:30 p.m. Mars is now in the west, and it sets around 9:45. So if we get out once it's dark, we might be able to still see that. And Saturn rises around 10, so once probably won't get above the trees for us to see it tonight anytime soon. And then Jupiter rises around 12:30 at night. Later in the year, these you won't be able to see these, but you will be able to see Jupiter at earlier in the evening. You can also see satellites, more and more satellites as time is going on.
Can't miss them.
Yeah, you can see here's the dotted lines, the picture of one. And I went to update this talk, which I gave about 8 years ago. I looked and saw, oh, there are different places where you can find satellites, live satellite tracking, sorry. You can just see, if you see a satellite, you can look up and see from one of these websites which one it is. Sometimes that's interesting, especially if it's a really bright one like the International Space Station. And then this is what the Starlink looks like now. All the time, and I find it interesting. I just took this picture when I was doing it, when I was updating my slides, and there's 3 trains of satellites or Starlinks that you can see that are coming like one right after another. So and sometimes you can see that across the sky. Just interesting, but not useful to see through for if you want to look at stars. Another thing you can look at are aurorae. Those occur. Oh, they have more information. I thought it was interesting to give a little explanation of how how you can see them. They're caused by particles released from the sun colliding with atoms of nitrogen and oxygen in the atmosphere. And the atoms give off excess energy, which gives off light. And the color depends on the type of atoms being energized. Oxygen produces red or green light. Nitrogen gives off green or purple light. And the Earth's magnetic force lines affect the pattern of the light, creating ripples, pulses, streaks, and sparks. You can also look at the sun. Obviously, you want to make sure you're looking through sun filters of some sort. If you have a telescope and sun filters, you can also see sunspots or solar flares. You can also see solar eclipses. The next annular solar eclipse is October 14th, 2023, which is coming up pretty quick. And the next total solar eclipse will be April 8th of next year. So to give you an idea of where to go to look, in the annular eclipse path is going through the northwest. So here in Massachusetts, you're only going to see about 20% of it, and that's less than 20%. So that's about what it would look like. So it's not terribly interesting. But the path of the total solar eclipse comes much closer than the eclipse. And it's kind of fuzzy, but we're in between the 85 and 90%. And unfortunately, this is blocking about what you see, but you can see much more of it. Yeah, there you go. So you can see between 90 and 95%. So that's what it would look like here.
Aha,
It's
it's haunted, that's the only.
Yeah.
explanation.
Another thing you can see at naked eye is double stars. If you take a look closely, this is the Big Dipper, as you can see. This is Alcor and Mizar. There's two stars here. And in ancient times, that used to be a test of your eyesight. If you could actually make out two stars there, you had really good eyesight. And you can also see asterisms. This is obviously the Big Dipper, like I said, is part of the bigger constellation called Ursa Major, or the Great Bear. So basically asterisms are patterns of stars that aren't actually constellations. You can also see the Milky Way if you're in a dark enough area, which is really spectacular. And you can also see, if it's really, really dark, you can see nebulae, globular clusters like M7 and the butterfly cluster. Thanks. And you can also see one galaxy naked eye. If you look closely, you can see it here. Yeah, there it is. And it has to be very dark in order to see that. You can see comets right there. I didn't get an idea of what comets are coming through next. When the next one is. I'm sorry?
This coming winter.
This coming winter, this is going to be one. Great. Let's see, and then if you see binocular, you get a pair of binoculars. So basically, that's what you can see using your naked eyes. If you get a pair of binoculars, you can see more things with greater magnification. So this is one of my favorite things to look at through binoculars, in the double cluster in Perseus. So it's very pretty. And if you get telescopes like the ones around the outside of the room, you can see even more things in greater detail. And this is one of my favorite things to look at. M81 and 82, two galaxies that are 12 million light years away. And they're interacting with each other. And you can find information about all this stuff that I described using maps, planispheres, guides, magazines, website, mobile phone apps. Just look up. And that's it. All right. Next.
Oh, yeah, just hand it.
Yeah. So forward and
Well, good evening. Before we when we were planning for this,
Michael suggested, maybe you should bring one of your telescopes and set it outside, so afterwards, people having learned about these, they could look. But lucky for me, I didn't have to bring it, because it's cloudy and it's gonna rain. That's our life in astronomy. This is the hobby you should have a second hobby. Open indoors, year round, do that. Okay, well, you heard about these different kind of telescopes. You see them around the room. All different sizes, shapes, prices. There are telescopes in this room that probably cost $100. There are some that cost like thousands, and there are some that are not in this room that belong to club members that are way up there, big numbers. So the question is, which is the right type for you? You know, you look around and say, what should I get? And it's a highly individualized choice. There is no universal right answer, except maybe the best telescope for you is the one you're going to use. It's not, you know, if you're in a third-story apartment, you probably don't want a big telescope that you'll never bring up and down. You'll do it a couple times, but then you won't use it again. You also won't get a telescope that's you bought in like a department store. You know, it's got a sign on it, 1,000 power. It's probably a piece of junk. The telescopes, they've got really flimsy mounts. The optics aren't so great. These are the kind that kids get for Christmas for parents that know nothing about what they should buy. They try it a couple of times, they get frustrated, it goes in the closet, they never used again. So the way to avoid that kind of mistake and determine what is the right one for you is to get some experience, talk to people like the people in this room. Some of these telescopes are more optimized for looking at the moon, details on the moon and the planets, the bright planets in the moon. Others, like the large one back in the corner where they got a big aperture, those are great for collecting light that you can see really dim things that smaller telescopes can't see. Some people love to look through small telescopes. Others, they say, you know, they're addicted to galaxies. They want a big scope. So you have to kind of find out what you want to do. And one way to do it is to go out, come to one of our outdoor observing sessions, where all these kind of telescopes will be set up. There'll be friendly operators. They'll probably be pi. Always little debtors. You can count on them. And you can play around with these. You can look through the different ones, decide what do I like. It's almost a guarantee that if you buy one, you're going to buy another one sometime because you'll figure out more about. You know, I'm kind of tired of that. I'm more interested in looking at galaxies or something. So I'll swap that one out, sell it to somebody, give it away, and you know, you kind of graduate into things that are more up your eye. So come out to one of our sessions.
Like the one July 22nd.
Yes, like that one.
Yeah.
July
22nd, did you say?
Yes.
July 22nd, Saturday.
Say, is that old Jim Kurth's telescope back there?
Is that old Jim Kurtz?
Is that it?
That's a much younger Jim Carter.
Yeah. But you see all these different kinds of scopes here. So you come out, you can try them out. This is Howell Point State Park, and this is our main observing place when we get those two great things. Saturday night, no moon and no clouds. Now this happens about 3 times a year. So any opportunities for you to come out. Some of us do stuff in our backyards. So here are the factors you want to consider if you do buy a telescope. Essential, get one with good optics. That when it's in focus, you don't get like all this fuzzy stuff, or it looks like a pencil or something. It's nice, sharp plane of light when you look at the stuff. Second essential, a mount that's really steady, and when you move it. And point it, it stays where you aimed it. Doesn't go. "Bleh." When the wind blows, it doesn't go. You know, because vibrations don't seem like much when you vibrate like that, but if you magnify that 100 times, you know, it starts going. No good. So those are really essential things in any telescope you buy. Transportability. You know,
Buy a van.
Mr. Van. Yeah, big telescopes, you need a vehicle that can take it, although I have a. You know, a scope that stands this high, it's that big and. I don't know, maybe weighs about 70 or 80 pounds altogether, but it comes apart. I can get it all into my Toyota Prius. So these things, even the large ones, they come apart pretty easily. You can move it. It's just like, is it too heavy for you? Do you have to carry it up and down steps? If you go out to an observing site, you have to carry it 100 yards from your car to get it out. So those are the things to consider. Portability. Like I said, telescopes, you can find really nice little, what they call tabletop Dobsonians. That design like that one in the back corner, except it's only the tube's about that long, sets on a table. You can just carry it with one hand, put it in the car. It's a great starter scope. For 225, 250 bucks, you can get a really quality optics, solid with a mount, set it on a table. Or you could go the other way, you know, if you get into this, yes,
While you're on that particular telescope, we donated one to the Sawyer Library. You can check it out like a book.
Yeah.
And the Rockport Library also has one like of that exact telescope. You can check out like a book.
they have one in Hamilton Library.
Yeah.
Yeah, so, you know, I find that, you know, people, you know, once they get into it, they say, you know, this is an important thing in my life. So I'm going to spend more than $500. I'm going to put some money into this. But you can get a nice telescope for less than it costs for like a Nikon single lens reflex camera. People, you know, they see these things and start by saying, oh, that must cost a lot. See that camera you're holding? That was more expensive than its telescope. Okay. The other thing is size, not just the size, physical size, but Michael Lipton mentioned that the aperture, the opening, whether it's the lens or down at the bottom, the big mirror at the bottom. Aperture has a lot to do with what you're going to be able to see. Telescope, basically what it is, it catches the light. And the more light you can catch and squeeze into your, focus into your eye, to your retina, the dimmer things you can see. Think of it this way. You got a jelly jar, you've got a wash tub, and it's a rainy night, stick them both out on the driveway, come out the next morning, there's like a ½ inch of water in each one. But that little jelly jar doesn't have much water in it. The wash tub, it's got maybe a gallon. In the same way with light, the bigger that lens, the more light it's going to capture and focus into your eye, so you can see dimmer things. I think I've got something here. There's an Israeli astronomer, it's really nice sketching. So this is kind of what it would look like to your eye over here on this side with a small telescope compared with large, medium size or a larger scope in this, looking at the same object. See the difference here, how much light you can get. And except for, you know, the brighter planets and the moon, the things we're looking at are dim. And the more light you can capture, the more, you know, things that you can look at. It's kind of like peeling back the skin of an onion. You got a small telescope to start with, you're happy, you see all the brighter things. And so if you want to see the things that beyond the range of that one, you got a bigger telescope to trade with. bigger aperture will also give you, if assuming the quality of the lens or mirror is the same, it will give you, allow you to see finer details. You can use more magnification without it getting blurry. So here's the difference, like a small aperture scope, you might see this picture, the same picture, but higher, the larger aperture, which you use higher magnification. Same thing with the planets. The two biggies for most of us are Jupiter, it's one at the top, and Saturn at the bottom. And you can see lots of interesting detail on this, but you see the difference between a small cheap telescope. It's kind of fuzzy, you can't see much, but over here with a larger scope, you can see lots of detail. Same with Saturn. So if you decide on something you'd like, kind of what you want, where would you find one? And the best first choice, I would say, is people in this room or that stayed home to, or people in the North Shore amateur astronomy. I'm not going to name names, but there are people in this room who own 6 or 8 telescopes. They probably use 2 of them. And I think if you talk to them the right way, or if they're hard up for a little cash this week, they will talk to you about maybe parting with one. So, it'll be a good telescope. These people know what they're doing. We had one instance today. Mario was getting rid of one of his scopes and put a note out this morning. It was sold in 5 minutes. Really nice telescope. So members, probably the club is probably your best source. And every once in a while, somebody donates a scope to us, and we'll ask for a donation. We'll give it to them for really good things. So stay tuned. If we get one that's donated, we want to sell it to raise a little funds for the club. We'll send out a notice. Okay. Other place to look is Cloudy Nights. That's an online thing that a lot of us look at when we're home at night on a cloudy night. It's got like a trading post where you can exchange, where people will list their equipment and say, I have a picture of it, how much price, etc. I bought some really nice binoculars. I think we all bought eyepieces, things which sold things on Craigslist, eBay. First good telescope I bought before I joined this group. So I got a 10-inch Dobsonian, I think for about $600 from Craigslist. This guy lived out in North Andover. He was having health problems. He had to quit. So I took it off his hands. The other source are new things, and you won't find these things, like I say, good ones in department stores. They're no longer around, at least around here, dedicated stores for telescopes. We can go talk to a salesperson. Most things are bought online.
What about the Nature Company, though? They have telescopes.
Yeah. Or some say National Geographic telescope.
Yeah.
Yeah. Don't.
No.
So the other source are new. You can go to there are dealers like High Point Scientific, Astronomics, some others that sell all brands. And they usually have good stuff, and they have people you can talk to, get some good advice from books. So here's a page from Cloudy Nights.
I've got the links down there. Hang on.
Yeah, so here's one of their trading posts. So if you want to get say a reflector telescope, you click on that one, you'll have pages and pages of telescope reflectors you can buy. Here's a really nice one here. That's a great telescope. It's Celestron Star Sense 10-inch mirror for under $1,000. So, wow, this would have been a good one, huh? A Star Master with a Zambuto mirror.
I'm giving that away.
Yeah, $3,800. That's still a bargain. Would you say? And they also have equipment reviews you can read on this. Then the individual vendors, this one is Ryan Telescope at telescope.com. They show all their stuff. You click on that. Some of them have a video where the guy shows you how it works. You know what you can do with it. It's nice source material. And then there are these vendors like this one, High Point Scientific. They sell all different brands. Here they're showing off their Celestron telescopes, also a good source. But so go into this though, really talk to us. I mean, we're here, you know, we can hear at our monthly meetings, we're out in the field, come out, try this stuff out. So once you do all that, let's say you get a telescope. Now what are you going to do with it? And I always say there are three big questions you have to answer as a new amateur astronomer. What should I look at? Where will I find it? This big dark thing overhead. And what is it? If I find it, what am I looking at? And that's kind of where the fun and the learning begins. So that's a whole lecture unto itself. So any questions before I hand over the baton? Okay.
Folks, any links that are in these presentations, I'm going to send out on the listserv this weekend. So you don't have to try and write them down or take pictures of the screen. Okay?
All right.
Now you tell me.
Okay, so I'm just gonna give you a quick thing. This is about what we call digiscoping, which is what I call point and shoot astrophotography. We have several astrophotographers in the audience. We have one extremely good astrophotographer in the audience, so I'm not gonna try to say too much. But digiscoping is point and shoot astrophotography, and basically digiscoping is you use a digital camera to record images by coupling it with just a telescope. And it's an updated version of technique called afocal photography.
Okay, that was me because I moved something. It worked for now.
Okay, and basically what you're going to do is you're just going to point the lens of the camera into the eyepiece of the telescope, press the shutter release. That's it. So there are ways to improve your ability to take the pictures, anti-vibration algorithms. So that's something that you can, that's software in the phone. Actually, all of your phones have anti-vibration algorithms in your automatically in your photographs, because what most of you don't realize is that you're shaking a lot when you're taking those pictures with those phones, and the phone actually is figuring out what's important and what's not, and tries to fix it for you automatically. And then the other thing is you can use an adapter or a coupling to align and stabilize the camera. And these are three different kinds. One the top two quite obviously are for iPhones. You know, so the one you put your iPhone in it fits right over the eyepiece, and the other one sort of grabs the eyepiece and allows you to adjust and maneuver it. And it's quite nice. It's a little pricey, but it'll get you there. I have something similar to the thing in the bottom that I put on a small digital camera, and that works pretty well. You use an auto timer to damp out the vibrations before releasing the shutter. So, you know, you set it and it cuts off 10 seconds and then opens the shutter. And then the other thing to remember to do is increase the ISO or the sensitivity. I always recommend starting at the maximum ISO that your camera has, and then you can always decrease it. But at least with the highest ISO, you'll typically get an image to work with. Many people start too low and they're like, all I see is black. And so that's because their ISO is too low. And then the other thing you can do is increase the exposure time, which will allow you to collect more light. all the background pictures in the slides were pictures that I took using my digital camera attached to my 3.5-inch Matsuko Cassegrain catadioptric telescope. So there's M13, the moon again, the eclipse, the ring nebula, and Saturn. Okay, so you can do it, it works. Now, the last thing I want to point out is this just came out. I just heard about it like 2 weeks ago. There's this thing called Solar Snap, and it's the Eclipse app. So the only thing I want you to remember from this is there is this thing called Solar Snap, and if you want to try it, you have to go to their website. But the thing that it does is it gives you a filter that you put over the lens of the camera, so that prevents you from burning out your camera. And then so you put the filter over the camera and attaches with a piece of Velcro, so you can take it on and off, but then you've got the little fuzzy Velcro on the back, and some people care and some people don't. But basically then you can take a picture, shoot it, take the picture, and then you can share it, and you can go to the website is eclipseglasses.com. Or you can just type, put in the search engine Solar Snap, and it'll get you right there. And it's about $12 or $13. And what's nice is it's something that will allow you to take photographs safely of the two upcoming eclipses, the annular eclipse and the total. And so this is just something that's just brand new. I mean, literally, I only found out about it about 2 weeks ago. So that's it.
Thank you.
What a polite, attentive audience you have been. Now it's your turn. We're going to talk about the 10 most important things you're going to take out with you when you go observing. And I need your help. I'm going to give you some hints. We're going to count down from the least to the most important. Shout it out. Help me out. Okay, you've gathered up all your gear. You've had your dinner. You've taken your car. Out you go. The hours go by. Midnight, you might be what?
Sleep.
Okay, now you're gonna be so enthralled by the sky.
Cold.
Cold, yeah, what else? Okay, we're coming to that. Okay, go ahead. Hungry, cold, yeah. So you want to bring some additional clothing. And you also want to bring something to give you a little energy, preferably something to share.
Something from Little Debbie.
Oh, my God.
Okay, number 9. How can something so small cause so much problem? We are, what are you gonna need, obviously? What are you gonna need? Yeah, do not forget this.
That works.
Yes, indeed. There are also some little battery operated things that people try. But whether you bring something, topical that's a spray or a lotion, don't forget it.
That's my pet mosquito scooter.
All right, and you're gonna keep that away from the telescopes. Okay, on to number 8. You've been standing for hours. You've been looking through your eyepiece. You're
Looking
gonna.
through the wrong end of your telescope.
You notice that? You notice that? Yeah, that's wrong. Okay, comfort. Think comfort. What are you gonna need for the hours? There we are. A chair indeed, and there's many different types of observing chairs. These are adjustable, but just bring something so that you can rest your weary bones. There's a variety of these. Okay, number 7. Oh, the night dampness and humidity affect not only you brought your clothes, but they also affect your lens. So how are you going to handle? What are you going to do with the dew?
Why?
No wiping.
No,
Yes,
no, no, no.
indeed. No wiping, no wiping. There's a couple, actually, somebody in this club brings a hairdryer out. I know that, am I right?
Yeah, absolutely, several of us do.
Okay, okay. But there are a couple of things that you can do. On the right, you see this, the blue tube, that delays the condensation from developing. And on the left there, you see, it's a strap and you plug it into your battery and it actually,
Since you did say white, but just everyone should know, white the optics, you're gonna take off the coatings. Don't do that.
so be prepared with something. Okay, number 6, you're out there. You see, you've got a clear night, you're looking around, I mean, where do you begin? What? I think Dick mentioned this, you have to have some idea, too much stuff, what are you gonna bring, what do you need? Okay. Okay, there, and they've been discussed before, there are many, many charts available, there's also stargazing apps, which have been mentioned, they will help you, and in the next, I think. Okay, now when you go on a trip. You make notes sometimes, keep a little travel log, a little diary, when you're out traveling the heavens, traveling across the sky, it's no different. You're going to need something to record what you have seen. So bring an observing notebook, pencil, pen. I've actually gotten an app now that I can dictate because your paper gets soggy, through the night. But I can dictate in and then transcribe later on.
And you can get little voice recorders on Amazon for cheap.
Yeah,
They fit in your shirt pocket and they.
and they don't get
all
stuck.
Yeah.
And they don't get stuck. But something to record what you've seen. I mean, it's amazing. You'll want to look back. Okay, number 4. When you go on a trip, don't you plan ahead what you want to see? You want to see this versus that? It's the same when you're traveling across the sky. You're going to take you're going to decide ahead of time what you want to see. Here's a picture of, what have you got there? What numbers?
Those are the Messiers.
Not all of them, but some of them. And there's, on the left, Sky Safari. It's an app on your iPad or iPhone. And it'll tell you, based on your longitude, latitude, the date and the time, it'll tell you what's up available in your spot to see. So at least if you go out with an idea of what you're going to look at, you'll be much better off. Okay, number 3, right at the top of the observing etiquette. Right at the top. Anybody want to hazard a guess? What is something extremely important? It has to do with visual acuity at night. And for not only for your sake, but for others, it's extremely important. Bring a red light. Can the white light, whether it's on your phone, on a flashlight, nothing. It takes a half an hour for your eyes to adjust to the dark. You get a flash from the car lights or something, you're back to square one. Okay, number 2. Now you wear different glasses. Some of us, I wear different glasses for reading, for distance. I wear different glasses when I'm out in the sun. Likewise, you need different things to use depending upon what you want to see. Anybody want to hazard a guess? Eyepieces and
Tinted lenses.
Years.
okay.
Filter.
Filters, yeah, the filters make a great deal of difference in observing the detail in various celestial objects. And then the eyepieces have been discussed, but do not forget those.
I have.
I have as well. Okay. Number 1, you've got a lot of stuff to remember. So a checklist isn't a bad idea. Even, yeah, it's not a bad idea. So you think, do I have everything? Now, what's the number 1 big thing to bring? So, number one, here's our own Dick Lukey.
Who's that handsome fella? Ah.
So now you're ready to go observe, enjoy the night.
Thank you. All right, folks, time to check out the telescopes and the mirrors that are half round, and if there's any snacks left over there, eat them quick. Thanks for coming. Leave the chairs out tonight. You gotta leave them for us for Saturday.
Thank you, Michael.
Okay, thank you.
Michael, is there any way you can show the Zoom folks what the telescopes look like?
Hang on.
Well, it's summer.
I was like, next Saturday is gonna be a good one.
Patty, what was your question?
I wanted to know if there's any way you can show the telescopes to those of us on Zoom.
Well, yes, I can.
Wow.
Keep recording.
Dennis, you're upside down. There you are.
How's that?
That's better.
I'm having
Whoa.
all kinds of weird problems over
I
here.
Where'd you
noticed
come
that,
from?
yeah.
The video breaks up and everything.
Ready.
It's a good collection.
Yeah. I'm not surprised.
Michael, is your telescope inside?
On the far left is kind of like mine.
I pretty much have everything in my closet.
A telescope hoarder.
There you go.
And I have a 13.1-inch Odyssey too.
Wow.
One of the originals.
Right now.
Still use it a lot?
No, I
You're
have trouble
probably right,
lifting it.
Fritz.
And I have no car that I can hold it in really any longer.
Oh,
You can turn that on.
Potato salad. Awesome, Brenda.
What's Steve doing now?
See you in the morning.
looks like a good crowd, Michael.
Yeah, it's nice.
It is, it's always really popular. It's the first one we've done since COVID. So the response is quite positive.